going to take a look at an example where the graph of the feasible region is already presented so that you don't have to do that work. And you just have to remember what type of feasible region is being presented, what types of solutions you would have in that situation, and then find those solutions. So let's take a look at that. We are presented with a bounded region here. I can put a circle around that, for example. Let's see if I can do that real quick, just for demonstration purposes. There, I've covered it up with a circle. So that is a bounded region. And we just saw not too long ago that in a bounded region, there's both a minimum and a maximum for the objective function. So we are asked for the objective function z equals 2x plus 3y to both maximize and minimize the objective function. And the way we're going to do that is to find out what our corner points are and create a table, do the calculations for both, do the calculation of 2 times the x coordinate plus 3 times the y coordinate to get the value of the objective function, and then do some comparing. Okay, so reading this off, the table I've created, I've gone around, looks like starting at 1, 4 and going around counterclockwise, 3, 1, 5, 4, and back up here, 3, 6. And remember, our objective function was z equals 2x plus 3y. I don't need to see this anymore. So since I've read off the what the corner points are, and so doing 2 times 1 plus 3 times 4, 2 times 3 plus 3 times 1, 2 times 5 plus 3 times 4, and 2 times 3 plus 3 times 6, etc. And we get our value of z for each corner points. Now, arithmetic is something we've been doing for a long time, and comparing numbers, something we've been doing for a long time since we were kids, but make sure you're not being too fast and too sloppy. So, double check those. And then we've got those 4 values. I've lined up all 4 values left to right, least to greatest. So which is producing the minimum and which is producing the maximum? Our largest value of z is 24, which is being produced by x comma y equaling 3 comma 6. Notice that we don't want to know just the maximum value, and we don't want to know just the corner point. We want to know which corner point produces that maximum value and what that maximum value is. Similarly, for the minimum, our lowest value of z is 9, and that's produced at the corner point 3 comma 1. Hope that helps.